We're now asked to describe the range of this transformation. So again here I might start by considering just, let's just let P be some, let P be some element of P2, which again is the collection of polynomials of degree 2 or lower. So that means that P of t could be written as a t squared plus bt plus c. Any polynomial of degree 2 or lower could be written in this form where a, b, and c are some real numbers. Okay, well then this P of 0 quantity is a times 0 plus b times 0, if we substitute 0 for the t's, plus c. So P of 0 is just going to be that constant term c. For whatever polynomial we pick out of P2, P of 0 is just going to be equal to the constant term. So the transformation of a polynomial P in P2, it's defined as P of 0, P of 0. But so that's just the constant term c in the x and y entries. Okay, so anything in the range is going to have this form. Okay, so a couple ways we could describe that. So we could describe it as the set of all multiples. If we pull out c, it's the set of all multiples of or set of all scalar multiples, I should say, of the vector 1, 1. So one way we could describe the range, if we wanted to describe it in set notation, is the collection, or it's the span of just the single vector 1, 1. That's another way we could look at it. Or the collection of all, let's see, multiples c times 1, 1, where c is any real number. Okay, so we could describe it that way. I also wanted to look at this graphically. So we know the range looks like that. We haven't thought about things graphically too much lately. So the vector 1, 1 would be something like this. Goes over 1, up 1, if we wanted to represent it graphically. Now if we want to represent all scalar multiples, well, if you had a positive scalar multiple, then it'd be, either shortened or lengthened depending on whether c is greater than 1 or less than 1, but it would be something along this line right here. If c is a negative multiple, it would flip in the opposite direction. It would be something along here. No matter what, the range is going to give you some vector along the line y equals x. And so graphically, that's the way we could think of the range of this transformation, is just, it's the line y equals x.